love the part where the frog actually ate the cat.
Oh yeah, totally. Hey Nawar.
Yeah, Jane? Yeah, I love the part where the frog actually ate the cat, though.
Oh yeah, totally. Hey Nawar.
Yeah, Jane?
I was watching Dunkirk the other day, and you know that scene where Tom Hardy is in the Spitfire and he's kicking all the Germans' butts?
Yeah, that's my favorite part.
Yeah, so I was wondering how he actually flies the plane in the movie.
Well, you see, Jane, it's simple physics. First, we need to start off with how a plane actually gets into the air. The engine is going to move the plane forward on the ground at very high speed. When this happens, the air is going to flow very rapidly over the wings, which then causes the air to be thrown downwards towards the ground. That generates an upwards force, which we call lift. It does exactly what the name implies. It lifts the plane into the air as soon as the weight of the plane is overcome by this lift. So it amounts to a pressure difference.
Hey, isn't that Newton's third law? Like the hot gas from the engines push the plane forward and cause it to accelerate, while the wings push the air down.
Exactly. The wings change the direction and pressure of the air to make use of it.
Does that explain why plane wings have the characteristic shape?
So most wings have the basic design of being curved on the upper surface and flat on the lower surface. This is called an airfoil, and when the plane flies forward, air splits in front of the wing, causing some air to pass over the wing and some to pass underneath it.
This sounds like Bernoulli's law. So this means that air pressure will be lower on top and higher on the bottom because fast-moving air occurs at lower pressures.
Why the wing then curves downwards is so that the air spreads out over the surface, and this means that there's less air on each point of the wing, and that means that there's a lower pressure.
Right, since it's the same amount of air but over more space, and then the opposite would be true with the air underneath. But how does the air from the top and the bottom collectively move downward? Why doesn't the air just split and keep traveling horizontally across the wings and trail off behind it?
You'll want to think about how a helicopter flies in this case. A helicopter generates a downwards force by spinning its propeller blades and bringing air above the plane underneath it. This isn't as obvious with the wings of a plane, but the same thing is going on. So before, when you mentioned Newton's third law, that's exactly what's happening here. The upwards force generated by the lift must be equal to and opposite to the downwards force of the plane's weight. And remember that a big part of that comes from the wings of a plane being slightly tilted downwards.
Oh, so if they're tilted downwards and there's that pressure difference between the top and the bottom, the air on top will essentially be sucked down. But that begs the question of what happens when a Spitfire, for example, is spinning upside down through the air. Why does this angled wing work in that situation?
It comes down to the angle of the wings. If the plane can tilt itself so that the wings have the same angle as they did when the plane was upright, we should generate a similar amount of lift. So by using what are called elevators that are on the tail end of the plane, the pilot can change the orientation to give it enough lift to keep the plane up in the air.
Alright, I gotcha. So then let's talk about steering since we're on the subject. If the plane is going to change direction, what does the pilot need to do?
So the pilot kind of has to lean into the direction he wants to go. Tilting like this will cause some of the lift to act sideways and will push the plane in that same direction.
That sounds like a centripetal force. So instead of the plane going in a straight line with uniform lift, this redistribution of forces will push the plane inward.
Yes, but this will cause the plane to lose altitude at the same time since there's now less of an upwards force. But the pilot can compensate by using the elevators at the back of the tail and a bunch of other components that change how the plane is moving, like the rudders, spoilers, and air brakes.
Cool, so in the case of Tom Hardy in Dunkirk, it seems like he was the most successful in the dogfights because of his maneuver tactics. The Spitfires could travel up to 560 kilometers per hour.
Wow, that's actually really fast for a plane from the 1940s. It's crazy how we can make something that impressive by only needing to understand a few basic physics principles.
Hey Maverick! Yeah. You hear about ice? What's that? I feel the need